My name is Stacy Hutchinson. I have a bachelor's, master's, and PhD in civil engineering. I have worked at Kansas State University for the last 23 years. My current position is the Associate Dean of Research and Graduate Programs in the Carl R. Ice College of Engineering at Kansas State. I started this position 4 years ago. Prior to that, I served as a professor in the Biological and Agricultural Engineering Department, where I worked up through the ranks from assistant professor to full professor in the areas of ecological water resources. So with a particular focus on the integration of natural systems into engineered systems for both water treatment, water storage, kind of as well as land management systems, because I work in Kansas where we have a lot of terrestrial systems that interface with our water resources. Prior to joining Kansas State University, I worked as a postdoctoral researcher with the Environmental Protection Agency at their Ecosystem Research Laboratory in Athens, Georgia.
So I believe you also have a role at the Engineering Research Visioning Alliance, or ERVA. I believe it's ERVA, right? Not ERVA?
It is ERVA, yes.
Okay, could you summarize what you do at ERVA, what ERVA is, and what are its goals?
So ERVA, or the Engineering Research Visioning Alliance, is an NSF funded organization that works to pull or create one voice for engineering and developing kind of the understanding the nascent areas of need for engineering research. I currently serve as the chair of the Standing Council. The Standing Council is 37 members from industry, academia, and government that represent a wide range of engineering areas that work together as we're deemed kind of the brain trust of ERVA, and we work together to develop the visioning themes that ERVA then works on in creating these reports and assessing where research is needed to push engineering forward and kind of safeguard the society and our economic prosperity and health and all those things that engineers are so responsible for in the world.
So we're here to talk a little more about the water side of infrastructure. So what are your thoughts on the state of water infrastructure in the United States and worldwide? And how prepared are we for the water problems we are having now and are going to have in the future?
So water is my passion. I've been involved in water resource for my entire career. And I pushed hard with ERVA to do a report in the water arena because of a concern, a very siloed look at our water system. Historically, if we looked at the consulting world, we had drinking water, we had wastewater treatment, and we had stormwater management. And that really then didn't even interface into the natural system. And so as we start to look at moving forward, I think we need to accelerate our ability to create a system that integrates the kind of the human water system needs, the other industrial and energy water system needs, as well as the natural water system needs. And how do we create a framework that brings all that together? I think without a uniform or integrated water system management platform, we will struggle to be able to meet the demand that we have for our human populations, as well as even provide services like electricity and energy because of the high water needs for energy development, manufacturing, food production. So much of this, I'm concerned about the future and the lack of integration, and really the emphasis of this report was to bring together all of the different groups from academia, industry, and government to have a discussion on how we unify those different silos of water into one system and what technologies or what research is needed in order to push that forward from an engineering perspective.
Okay, so you've mentioned this report a couple of times. I believe it's officially called the Engineered Systems for Water Security. Is that correct?
That is correct.
Okay, so you talked a little bit about it. Could you talk a little bit more about its goals and then what you thought were the key findings from this report?
Really, the goal of this was to bring together those voices from across the water users. So, again, both academicians that work in water from different areas and aspects of water, including drinking water, wastewater treatment, natural water systems, with industries that play in this arena. So again, you can be thinking about our consulting firms that are building a lot of that built environment that delivers water to the human system, as well as kind of treats our wastewater. in addition to government officials. So how do we start to put government officials in with industry and academia? What is it going to take to kind of pull all of these different pieces of the water system together? So the report really, or the visioning event, brought all those groups together to have the discussion as to how do we move forward. I think our major kind of findings when this were, number one, there was a great appreciation kind of from all the sectors of what was needed. We started to talk a lot about this integrated large scale system. I think every group there was able to see that if we could pull up the vision point to a little bit higher perspective and create a larger umbrella, that we could be more effective with that management system. There was also a lot of discussion on the need for new technologies. Do we need new desalinization plants, so that as we think about areas that are struggling with lack of water, how do we create more potable water from marginal water supply systems? So we talked about technologies like desalinization. We also talked a lot about technologies, say like that could create the biocircular economy. So filtration systems and water treatment systems that allowed us to take that traditional comment from toilet to tap. How do we get that process so that we're losing less water in that system? So again, thinking about components and technologies that are needed that fit into this overarching management framework. And then I think the final big piece of that was the data collection and data analysis, and within the integration of AI. So as we build these new systems, hopefully also with components that fit readily into our current systems, we can start to collect more information that allows us to start to manage those systems better. For an example on that, we have a lot of aging water systems where we're losing a lot of water after treatment. So we invest a lot of energy into creating potable water. We lose that water through transmission. How can we use, say, different acoustic sensors and data collection systems to improve upon that water delivery system, or even know where we have issues within the system that we can fix that, so that we take a limited resource, we invest less money into treating that to the level that we need for the service that we're trying to provide, and then we're more efficient in that whole process with respect to water conservation and water and energy use in the whole process.
So now I'm kind of wondering, what would you say from what you learned in the report, kind of more on the practical side of things of what people can do? What should like our engineering audience need to know from this report so they can create better water infrastructure designs, models, and systems? What would you tell them?
Again, I think the biggest thing is being cognizant that we really only have one water source. And so that one water loops through all of the systems that we're talking about. So as we're designing our wastewater treatment systems, maybe we're starting to think of that more than a wastewater treatment system. We're starting to think of that as a resource recovery system, where the resources that we're recovering include both clean water, as well as maybe nutrient sources that can be used back into our food production systems, rather than investing energy solely for the recovery of water from the system. I think so. And then looking at taking that back into the drinking water system. So we're creating more of a cycle and understanding that each of these systems is linked together, that we're solving this for one water system that is at the nexus of what we need for our human lives and health and safety. As well as how we manage our natural systems, so that the adequate water is there to support our ecosystems and the natural environment around us. Also then integrated with what are we going to need in our engineered systems with respect to, say, manufacturing or energy production, which are also can be very water intensive.
That's great. I think those are really important ideas for people to learn. But I'm wondering, are there some very specific action items or advice that you might be able to give engineers, either from this report or from your experience, that they can kind of incorporate what they're doing to make changes in a kind of a very specific, tangible kind of way?
I think one of the hard things, and I appreciate pushing me to be a little more specific, and I think that's one of the challenges in trying to get people to discuss water. Water becomes very site specific, but yet it's still a global problem. Water, there's a global water cycle that we're trying to manage then pieces of in our own area. And I think one of the issues as you think about, maybe it's just becoming very informed about what's going on around you. I happen to be in the middle of the country. My water system is a riverine system. River flooding dictates a lot of the challenges that we have around here, as well as droughts as we move further away from the river system. which is very different than what's going on in the coast, where there's a lot of concern with sea level rise and thinking about large hurricane storms or events that bring in very different water dynamics. So, I think that while they might be a little bit vague, I think the two things are really understand the water system and understand the connectivity of those various components of the water system, and then put that into context of where you are, but appreciate that when you do work in another part of the country, that might have to twist a little bit. Again, what I have in Kansas is not what's going on in Southern California, nor what's going on in Florida. But yet we are still working in all those regions, particularly when we're, working in engineering consulting firms. So understanding, all the components, from the natural component to the built component to the engineered component, how do those all play together when you're in a very different environment?
Okay, that makes a lot of sense. My particular environment in Colorado is droughts and forest fires, so it's a little different, but it's all part of the puzzle, right?
It is all part of the puzzle. And I think that's one of the, it's one of the things that concerns me when you think about water, is just, again, understanding, you kind of get your local perspective of what water means. You're not too worried about sea level rise in Colorado, just like I'm not in Kansas. And we're learning that even across the country, they can be worried about forest fires these days. But again, those dynamics change depending on where you are. And so then that kind of sets what you value and believe is important. And I think it's important to keep in mind that the basics stay the same, but maybe the value system changes a little bit as you go to different regions.
Okay, that's great. So now that you've completed this report and you're getting the word out, what are maybe some of the next things that you think you're going to be working on in this kind of angle, in this aspect?
I think this report was great because we were able to bring together those key groups of people, academia, industry, and government. I was very pleased to see the great conversation and kind of understanding of maybe where we need to go. I think now it's kind of continuing to work on understanding the continuum of impact across those stakeholder sectors. Academics tend to work on the kind of that foundational research, which is really, again, the benchmark of NSF and how we push things forward. But then needing to understand, what does it take to get that new technology or that foundational work actually ready, a technical readiness level that we can build and implement. So to me, I think that's some of the next steps as we start to think about whether it's desalinization plants, or I'm working on a colleague right now on an anaerobic membrane bioreactor system. How do we take those systems now and get them to the point that we can truly scale them and have them have an impact on water security? They might work great, at the benchtop scale or the pilot scale, but it really, it's a whole different ballgame when you start talking about having to provide safe water across millions of people over large spaces. So I think that, to me, is the next step, is thinking about that continuum of technical readiness and how do you move those technologies into truly having an impact in our society. The big thing for me is we have one water. As much as I'd like to create some engine to create new water, I'm not certain that's the right way to go. So just figuring out a way to how to manage that water that we're effective for not only us within the United States, but globally, to provide equitable water to everyone.